Hello, and welcome to OPW's continuing series of instructional videos on retail gas station equipment. You may have already viewed our initial series of 101 videos where we showed you an introductory high-level overview of how a retail gas station operates along with the types of equipment typically found at one of these facilities. We also covered some of the terminology and acronyms used in the petroleum world. So if you're new to the petroleum industry and are watching this video, you may want to go back and watch the Retail 101 series of videos before watching this video. OPW is the world's largest manufacturer of petroleum handling equipment in the world. Our job is to make products that keep critical fluids from entering our ground, water, and air, and to provide a safe refueling experience for our customers as well as the environment. In the next chapter of Retail Topics in 201 series of videos, we'll get a little more in depth and talk about each product group specifically, along with some technical information. Today, we're going to focus on what is called overspill or overfill prevention. This type of equipment is commonly referred to as overfill prevention valves. So if you've already viewed the 201 video on overspill protection, you know that in 1988 the federal EPA required all new underground storage tanks, or USTs, being installed to have three things: overspill or overfill protection, overspill or overfill prevention, and then some type of overfill or overspill detection. All existing USTs then had 10 years to update and install this type of equipment. The primary reason this rule was made was due to the fact that it was discovered a large amount of fuel was being introduced into the ground and eventually into groundwater and drinking water. It was discovered that this was not necessarily occurring from leaking tanks, but actually at the point where the tanks were being refilled. In those days, there were no means to contain or collect any spill or drips that occurred during the refueling process, and there was no means to alert or prevent a driver from accidentally overfilling an underground tank. And as of July 2015, the EPA now has released new sets of regulations stating that these overfill prevention devices must be tested every 3 years, but we'll talk about that in a little bit. Originally, there were three forms of overfill prevention devices: ball floats, overfill prevention valves, also referred to as OPVs, and tank alarms. However, as of October 2015, ball floats have been banned by the federal EPA as an approved overfill prevention device. In addition, tank alarms are not widely used in the industry as an overfill prevention means. The alarm must be audible and visually located where the driver will be making the drop. The problem with this type of device, as well as the ball float, is that it requires the driver to actually take action. This is why the preferred method of overfill prevention has migrated towards the use of an overfill prevention valve. These are also commonly known as flapper valves, float valves, or shutoff valves. So the way this works, each valve is installed specific to that tank. And what will vary is the diameter of the tank or the actual burial depth, how deep the tank is buried beneath grade. So that'll determine, the contractor or installer will use instructions provided by the valve manufacturer to determine what length the upper tube will be cut, as well as the lower tube of the valve itself. Once the measurements are made, the valves are cut, the two pieces are put together, and then he drops the valve down through the riser pipe, through the spill bucket, down into the tank. So now the float valve is positioned exactly at 95% capacity of the tank. Once the valve is in the bucket, he'll go and replace the nipple riser and the adapter, and the valve is ready to go. So the valve works by liquid rising in the tank and moving a float, which closes a poppet into the flow of the product, and the valve slams shut and alerts the driver that the tank has reached critical capacity. The driver then shuts off the flow of the product from the truck. There's actually a second valve in which it allows the remaining product in the hose to be drained into the tank. If the driver fails to shut off the product from the truck, the flow will reach a secondary stage, initial stage, secondary stage, and will shut off all valves and not allow any product to enter the tank. Because the overfill valve will work regardless of the driver interaction, this is why it is the preferred method of overfill prevention. So the valves come in different styles. They can come with an external flapper float, or they can come with an internal float. In the 202 series of videos on overfill valves, we'll explain why the external float is a better design. The valve also comes in a vapor-tight and non-vapor-tight version. With the adoption of EPA's 40 CFR rules back in 2011, most facilities now should be using a vapor-tight version of the valve. All right, so let's take a look at each one of these valves a little closer. So the valves come in the standard configuration, which would be found at a typical 2-point drop We talked about that in Retail 101. These overfill valves can also come in the coax version, where you actually have the fuel and the vapors coming up through the same opening in the tank. And then finally, the valves can come with a testable feature or option. Now, with the new EPA regulations released in July of 2015 that will now require the valves to be tested every 3 years, the testable version will probably be the best option moving forward. Okay, so let's look at each one of these valves a little closer. So this is our standard, what we call a flapper valve with the float mechanism that comes up, closes the poppet in the stream of the flow. This valve also comes in the testable feature, where in the previous valves, the only way to test a valve would be to remove it from the tank, make sure the flapper works, see that the valve closes as the flappers lift up, and then you would have to reinstall the valve back into the tank. The problem with that is it can take a long period of time, plus the valve may become damaged as it's being pulled in and out of the tank. So with the new testable valve, you can actually leave the valve in place, simply pull up on the test cable, lifts the float, and you can look down into the valve and make sure that the poppet's being closed. So it's a way of testing the valve without having to remove it from the tank. So that was the standard valve. And we also talked about the coaxial valve, where we allow product to drop down the center and then the vapors to come up from the outside. So you can see the design of this valve is slightly different to allow that to happen. So a standard valve or a coaxial valve. So what are some of the troubleshooting tips or things you may come across in the field that may affect the proper function of these valves? The first one is float interference. So what could potentially happen if the valve's installed in the wrong position inside the tank? The float may come in contact or come up against some other thing that's down in the tank. So when they're installed, the floats have to make sure that they are in the proper position to not be interfered with as the float rises when product comes up through the tank. So the other thing you may experience in the field with these valves is they may fail to pass a pressure decay test. Now earlier I talked about valves being vapor tight or non-vapor tight. So what that means is on a vapor tight valve, every connection where the upper body connects to the valve and where the lower tube connects to the valve, those are tight connections where pressure or vapors cannot leak through. And also within the valve externally, everything is sealed off. So what happens is when these valves are down in the tank, the valve is actually exposed to the ullage or the pressure that's in the tank. And when we do a pressure decay test, we test with the cap off, so the valve cannot allow any of that pressure inside the tank to leak up through the valve and come up through the atmosphere, otherwise it won't pass a pressure decay test. So after 40 CFR now, most of the tanks must pass a pressure decay test, and most of the valves must also be vapor tight in order for that to happen. So when choosing a valve, vapor tight or non-vapor tight, the preferred valve to choose is a vapor tight valve. And finally, one of the most common issues that we come across in the field concerning the overfill prevention valves is drivers trying to force these valves open. What they'll do is they may want to cheat and try and squeeze a little bit more product in the tank. So they'll take a gauge stick or some other stick on the truck and stick it down through the bucket, the adapter, and down in, and actually force open the poppet and keep it from closing during a 95% capacity or as the tank's being filled. So keep an eye out for that. If you do find, as you're doing inspections and you see something that's jammed down in the overfill valve, you want to report it immediately because it could potentially cause a problem. The valve won't operate properly and you could have a catastrophic overfill situation. So the way a ball float works is as the liquid level in the tank is rising, it's displacing the air that's located above the liquid, and that air has to go somewhere. So the air or vapor is actually forced through this opening here and then goes to our vent pipe and then goes to eventually our pressure vacuum vent that we talked about in Retail 101. So what happens with the ball float, when the liquid level reaches this level, the ball floats up and restricts the flow of the air trying to escape the tank. So now what happens, it greatly restricts the flow of product coming into the spill container and alerts the driver that the tank has reached critical capacity. So now the driver has to shut off the product coming from the tanker truck into the tank itself. That's it with our 201 video on overspill prevention. I hope it's been helpful. Stay tuned for our continuing series on the 201 videos as we look a little bit more in depth on some of the other products that you find at a retail gas station facility. Again, I'm Ed Kammerer with OPW. Thanks for watching.